So there is a broader conversation, I think, going on right now about more or less what the hell is DA, what the hell is data availability, and not just from a technical perspective, which we will also just answer that 101 question, but also qualitatively, what does it mean to have good DA? What does it mean to have bad DA? Is DA a commodity? What is the future of DA? Is it the bandwidth of Web3? What is its future role and trajectory as the future of DA expands? But in order to really just nail down the 101s, I want to just define data availability. It's a weird term. It's one of these weird terms that the crypto industry comes up with. Normies will hear it and they're like, this is whatever podcast I'm listening to is not for me. Maybe John, you can start by kind of laying down some foundation. What is DA? How is it a part of just blockchains? And why is it important?
Yeah, one of the many unfortunately named things in blockchain, which we've kind of realized after a couple of years still isn't super clear. So, I mean, it's kind of helpful to start with like the basic idea of like, what is a blockchain in the first place? It's like some way for us to agree on some form of shared state, and like we can update that thing and then we agree on the new shared state of the world. So like fundamentally what you want to have there is everyone knows what the state of the world is and then like knows what it's correct. And kind of fundamentally to do that, you both need to be able to like verify that this like new state that you've been told is correct, and also just to like have all the data there in the first place, just to know that and understand what it is. So like the most concrete way. So what you should also realize from that is like we always talk about it in the rollup context for the most part, but fundamentally every blockchain ensures data availability. Like that is just a fundamental guarantee of them. Rollups just kind of highlight it, and that we kind of like strip it out and think about it separately, which is why we've just always kind of like taken it for granted that every blockchain ensures data availability by default of full nodes just download all the data. And if all the data is there, then you know that the data is available. If the data is missing, then you shouldn't sign off on that block. That's like generally how any traditional blockchain would work, whether it's Solana, Bitcoin, Ethereum, et cetera. For rollups, the area where it gets highlighted and we see it differently is they are posting their data to another chain, to a chain like Ethereum, and you will see data availability. You need it for example, like the clearest example is for optimistic rollups. You can't make a fraud proof to show that like some state transition was invalid if you don't have the data available. So while it's something that we kind of like highlight and see differently in the rollup world, it is just fundamentally a guarantee that like any blockchain needs to have is, hey, if we're all going to agree on what like the state of the world is and everything about it, you need to know what the data is. So it's just like a very fundamental guarantee for any blockchain.
So John, if this is a core fundamental guarantee of blockchains, what do? They tell you whether the state of the world is true or not, right? Okay, so, and then we have in kind of these modules, sort of what we've talked about is the consensus layer, the data availability layer, and then the execution layer. One framing of this that I've had is like the consensus layer tells us like what's just happened or like what's true. I think of it like that. And the DA layer is like what's happened in the recent past. It's kind of like there's some history sort of archive associated with it. Tell me if that framing works for you or how you'd modify that in terms of what we're actually concretely talking about here.
So it's not so much the history, and this is part of the reason why I would say data availability was in a kind of unfortunate name in hindsight, because it does sound like that. But we're really referring to just a very like short-term guarantee of I am able to download this data and I know that it's available. It's not a guarantee that like you can go get the data from 5 years ago that Ethereum had or anything like that. That like kind of historical storage requirement is a little different.
John, Dankrad has called it data publishing. Do you like?
Yes. I definitely do think it is clearer. A lot of the other data availability people are also in favor of like Mustafa and Celestia. Like I think they're generally in favor of it. I think it is just so hard to like change the name of it at this point to something that is like probably a little bit better, but has just been memed into this gigantic thing over time. But that is a clearer way to think of it. And that is like actually how the idea was kind of described in the first place, like back in Bitcoin world. It's basically is this.
And when we say data publishing is maybe clearer because like I guess that's what in fact we are doing. When I think most normal people, they hear the word publishing, they think about it in a non-blockchain context. So they think about like publishing to the web, or I'm publishing my blog, or I'm publishing this podcast to my RSS feed, right? But when we're talking about data publishing, or AKA data availability, we'll use those terms interchangeably through the rest of this episode. We're talking about publishing that data to the blockchain, right? So, and again, what do blockchains do? It's sort of a truth computer for us. It's a truth engine. It's a trusted compute layer. So that's what we mean in this context of data publishing, yes?
Yeah, you could also publish to the internet, and that would be some form of data publication. It's just very bad DA, as opposed to a blockchain, which is the gold standard.
Okay, bad DA. Bad DA. Can we like unpack that a little bit?
Yeah.
Why is that bad DA? And can you like frame it up as like, okay, in crypto, did we invent good DA? So Neel, what did you mean by bad DA? And then maybe you can also go into what is good DA.
So to me, good DA is something that's one, verifiable. So anyone could determine whether DA was performed properly and whether the data was actually published. And second, it has better liveness properties, meaning that on the internet, theoretically, whatever web server you publish that to, they could refuse to serve you that block. And that's okay for archival data, just because you don't actually need that to determine the fork choice rule and to determine the current state of the chain, as John was pointing out, once you've already finalized a particular tip or a particular history. But for good DA, it's probably better to optimize on good DA for things like when you're in the active process of finalization.
So Neel, when you say good versus bad, right, we're starting to add some subjectivity to this, I think. And like maybe the question is like good for what or bad for what? Because I think the way I publish, my newsletter is probably fine for the purposes of a newsletter. It's just content that I'm trying to, I don't need sort of the trust guarantees of a blockchain, but maybe you might argue is bad for use cases like, let's say transferring millions of dollars, large amounts of value. So with what kind of context or what types of apps are you judging DA through this lens of good versus bad? Is it basically internet of value types of apps? You need stronger DA guarantees, whereas like just communications, regular old internet, copy paste, JPEG type apps, it's fine to just use the protocol layer of the internet. Yeah, tell me about that.
I think it's more about what's the threat if data were to be withheld. And sometimes that's a more meaningful way to think about DA in the context of a data withholding attack, meaning if someone didn't give you this data, what's the worst damage they could cause? And for example, for a blockchain, once something is already finalized, if they withheld historical data, that might mean it's harder to bootstrap a new full node and you can't replay history from the beginning of time. But at the end of the day, you know that there was some safety guarantee given by the fact that the whole quorum voted off on something and you had consensus at some point. Whereas if something has not even been finalized and someone withheld data, then you could actually have forks, you could have safety violations, and then it's much more meaningful to have good DA in those circumstances.
So what can happen if the data is withheld? I guess the stakes are higher with high value use cases like actual, peer-to-peer money transfers, that sort of thing. Whereas
so it depends on the blockchain. So for an L1, if you withheld data, then the blockchain would literally fork. And then you'd have two sets of participants, some which have seen the blocks and some which have not. And then it depends on who you're connected to in terms of what state you're going to be receiving. But if you're an L2, then that means that the Ethereum bridge could literally be compromised in the case of an optimistic rollup, where the executor could publish an invalid state root. And then theoretically, if the block were withheld, then no one would be able to wipe that invalid state commitment and it would eventually be finalized. So those are it somewhat depends on what the blockchain construction is to determine what's the worst case outcome of a data withholding attack.
Okay, John, I'm just, mining for data here. Do you have anything else to add to just explaining data publishing and data availability to normies? What else would you add to kind of tie us off? And then we'll get into the deeper subjects here.
I think we covered it well there. I would just finish it with like that simple mental model and description of publication probably is the right one for most people to think of it, in the same way that, you could publish something to any website and based off of that, we can have some reasonable assumption that like everyone saw that data. And if it was there for long enough, everyone should have been able to download it. But it's not a guarantee that like if you publish something that, a year later, the website, has taken it down or something else. But your data was published. And it's just a matter of like that strength of guarantee and that everyone saw it. And then we could all verify that together.
I actually do really like bringing in the Web2 database conversation here, just as a frame of reference, where we have like our censorable Substack or like our Bankless YouTube that was actually taken down one time and deplatformed. Our data was withheld from us. And this has caused issues in like the Web2 space, like we call it deplatforming. And then when you apply a new technology called a blockchain that introduces property rights and settlement guarantees, withholding data it's a similar problem, but now we're talking about that data was actually your money, like not just your YouTube videos. And so maybe that can help listeners come in and reframe this conversation for data availability. Jon, talking about it from an economics standpoint, data availability is a commodity. All blockchains have them. Bitcoin, so just like you said, it's a core part of every blockchain. If you are a blockchain, you have data availability. Your blockchain has qualitative properties. Therefore, the data availability of your blockchain also has qualitative properties. Bitcoin is data availability with a proof of work mechanism. Ethereum is proof of stake with layer 2s. But like data availability, it's a commodity, like it's a resource. How do we categorize this thing?
I think that's a good way to categorize it, is that it is effectively just kind of a base commodity that is kind of an input to most of these systems. The way that most people will use that term then is to kind of try to make the point of, oh, it's a commodity, like these different things are all the same, whether I use Celestia or Avail or EigenDA or Ethereum, whatever, that it's just a commodity, they're all kind of the same thing. That is the part that I would, in practice at least, kind of disagree with and push back on, is that like I would agree that in the limit of like if we have all these perfect systems and everyone is like, yeah, there's a bunch of perfect DA layers that have all the guarantees you want, then yeah, it should be like relatively fungible between them. Practical reality is there is a very large difference, I would say, in the quality of block space that is being provided by one DA layer versus another one today. Because otherwise you can take this to the extreme of we're actually back to the Web 2 of like posting your data online, is data availability in some sense. Like why don't we just put all of this on AWS? Like why do we need a blockchain in the first place? And so there very much is like this kind of spectrum of like there is different, I would say, qualities of block space. And there's different features that come along with them of whether it's, certain network effects of being in the same ecosystem together. Others lend themselves much better to data availability sampling, which means that people can more easily verify it. So there are these kind of like different features that definitely do differentiate in practice, like one DA layer versus another.
In the short to medium term, I think that's true. I think in the long term, pretty much all these folks like Avail, Celestia, EigenDA, the features like data availability sampling and having really good decentralized relayers will essentially become table stakes. Because if they don't have those baseline features, even things like soft confirmations to better support based rollups, these constructions will become so popular that if you don't offer the features that are conducive to those constructions, you'll just be non-competitive. So that's kind of how I'm thinking about it in the long term. And then Ethereum DA obviously is in a category of its own, assuming you're using Ethereum for the fork choice rule, just given that now your trust minimized with respect to Ethereum.
Okay, so there's so many things that like we just brought up there, but so David's base question is DA a commodity? And your answer to that, both of you, I think you guys would say yes, it's a commodity. And Bankless listeners have heard us talk about block space as being sort of the core commodity that this entire revolution has created. Like the thing that we made was block space. And is it accurate to say, Jon, that DA is just like one component of block space? And in fact, inside Ethereum on kind of like mainnet, before it sort of modularized and it sliced out DA as a separate part, it basically included DA as part of that block space. And just DA is just one component of the larger superset commodity, which is block space. Is that correct?
Yeah, I would agree with that. Yeah, really data availability and then consensus over that is kind of like the fundamental baseline of what any blockchain is like looking to, that you need to have and to provide for them.
Okay, and then Jon, you were making the argument that not all DA is the same. So like some commodities, like DA commodities have different properties than other commodities. But Neel, you were just saying, well, actually that's true right now, but over time they'll sort of fuse together. They'll become kind of like a baseline. This is the set of functionality and features that all DA has, and it will, I guess maybe another word is commodify, right? They'll all become kind of similar to one another. But then you made an exception there, Neel, and you said, but Ethereum DA might be in a category of its own. Can you say more about that? Like, why does Ethereum DA have any special status? And I would love Jon's take on this too.
So it's mostly because of the fact that rollups typically define their fork choice rule on Ethereum. And this is actually something that we were chatting about with the Celestia team just recently. They said, why don't you just define your fork's choice rule directly on Celestia in some way? And the reason for using Ethereum is that now, assuming you also offer forced inclusion on Ethereum, then theoretically your rollup could operate even if Celestia goes down. And that's a pretty big advantage. So by using Ethereum for DA as well, it means that even in the happy path, you're only relying on Ethereum, and there's no risk that Celestia going down could impact the safety or liveness of your rollup. So that's the reason why it'd be different. But for example, if you were to have a rollup that's settled to Solana, then I'd argue you should also use Solana for DA, because that would be the trust minimized construction for that kind of rollup.
Is what you're saying just there, Neel, is there's like a resonance between using the same layer for DA and settlement. Like if you're using both and then both are the same, there's just a little bit of sum greater than the parts that emerges when both the DA and the settlement are the same layer.
It's essentially avoiding the same issues that come with bridging. Because in order to use Celestia DA with Ethereum settlement, at some point you have to relay some data from Celestia, which is a signed data route. So everyone's posting their transactions to Celestia. Celestia Quorum signs off on some succinct representation of that, and that has to be relayed to Ethereum. And doing that in a decentralized and trustless way runs into the same exact issues that bridging runs into.
Understood. Neel, you've also used this term fork choice rule. Could you just unpack that a little bit for listeners who might not be familiar with that term? Just explain like I'm five what that means.
So let's say I have some set of transactions, and then I have an alternate set of transactions, and they lead to different state routes. How do I decide which one is canonical?
That's a fork in the chain?
Yeah. And then choosing which fork you should go on or which fork is canonical is the fork choice rule.
To continue leveling up your crypto game, then you need to get on the Bankless newsletter. It's the world's most popular crypto email and is completely free. Just click below to sign up.